All right, so thank you for letting me do this seminar for Reply Bhasana.
Hello and good morning to everyone. I am Anuj Singh, faculty from Kathmandu Research Institute for Biological Science. Today we have presenter Mr. Anuj Ghimire with us in Biomedicum Seminar Series, Episode 7, which is jointly co-organized by Kathmandu Research Institute for Biological Science, CRIB, and Research Institute for Bioscience and Biotechnology, WIB. Before moving to introduction, I would like to go with few housekeeping rules. The presentation will go for approximately 30 minutes, and then the session will be open for question, answer, and discussion. The session is being live streamed on social media and is being recorded for educational and training purpose. Without further delay, I would like to introduce our speaker for today, Mr. Anuj Ghimire. He is doing his PhD in Zoology from North Dakota State University, Fargo. He has completed his master's in zoology with a specialization in ecology from TU, Kathmandu, and bachelor in zoology from Trichandra College. He has gained a lot of experience in different research projects, which include growth, longevity, trade-off in House Sparrow nestling, climate change and impacts on indicator species, pattern of bird herd evidence and habitat, which is used in Gosaikund region, estimation of population and conservation of genetic dolphin in Karnali River, and it tributes and other related projects. Likewise, he has also published his research project in different publications. So without further delay, I would like to hand over the session to Mr. Anuj Ghimire for his presentation. Thank you.
Thank you very much for inviting me for the seminar. I'm really excited to share my research. So for today, I'm going to talk about one of my projects. It's one of my main projects for my PhD. I've kind of titled it differently just for this project. So the basic thing that I'm interested in is life history trade-offs. And then I'm looking at that in house sparrows. So the title for my presentation today is Life History Trade-offs, Growth and Longevity in House Sparrows. So if you think about animals, they have this finite amount of resources. So depending upon how much of those resources they can get, they only can invest a limited amount of those resources into various competing life history traits. Those life history traits can be anything from reproduction, growth, longevity, and DNA repair, cellular maintenance, and so on. But in nature, it doesn't always work properly. So they only have like limited amount of resources, and they must partition it in such a way that they can invest in everything, right? And then when they have to do that, when you spend a certain amount of resources in one of the traits, you can't invest another equal amount in different traits. So the easier way to explain this would be, one of the examples that I always use is the pizza slices. So let's say I'm with 3 of my friends, there's 4 of us, and then we have this pizza that's like 12 inches in size. But if I cut the slice like that with 4 equal slices, then that means everyone will get to like fulfill their hunger, everyone will get equal piece, and then everyone will be happy. But if I cut the first piece myself, which turns out to be one on the right side, or this one, so then that means other people won't get equal amount of food, which means they won't get to fulfill their hunger. So basically, if we kind of think about it, if this big size slice is the growth slice, then there's less for reproduction, less for cellular maintenance, and less for other life history traits. So this trade-off basically can occur throughout lifetime, right? So even if you think about student or anyone who works in a company or a bank, they have limited amount of resources, and they must partition that amount of resources into their apartment, food, their fuel for the bikes and stuff. And if you just spend all of your salary in food, you won't be able to pay your apartment rent or whatever. So this kind of trade-off exists in everything, in every animals, and then that can exist throughout their life history. But the major trade-off when it comes to investment usually happens during early life growth. So if we think about growth versus lifespan, if we look across species, so on the left side, if we look across that, smaller species usually live shorter life, and then larger species tend to have a larger lifespan. But when we look within species, so this is for between species, but when we look within species, we see that individuals of larger size generally have shorter lifespan compared to the individuals of the smaller body size. For example, if we look at Chihuahuas or Great Dane or Saint Bernard, those bigger dogs usually live shorter life, and then smaller dogs have longer lifespan. Similarly, if we look across like wild species as well, there's been this suggestion or there's a trend that usually is followed by most of the animals. For example, in this stickle backs, these are fishes. This experiment was carried out to see if accelerating the growth during early growth period, so during their growth period, affected their telomere loss or lifespan. And if you, as you can see, these dotted lines are the ones that were accelerated. So you can see that they had shorter lifespan compared to the ones that were controlled. So they were able to shorten the lifespan by 14% during this experiment. Though we know that there is a trade-off between lifespan and growth, the physiological mechanism still remains unclear. So we don't know why that happens or how that happens. One of the reasons could be telomere dynamics. So it could be an important physiological mechanism that can link lifespan and growth. So what is telomeres then? So basically telomeres are the protective cap at the end of our chromosome. It is a zone of non-coding repetitive DNA sequence. And while during the, it basically protects genome integrity and like help or protect it from getting unwinding. So I'll move on to the next slide to explain it in an easy way. So telomeres are like the protective cap, plastic cap at the ends of our shoelaces. So we've all seen that. And if we take that protective cap off, our shoelaces starts unwinding. And in similar ways, the protective cap that's at the end of our chromosome, which is called the telomeres, is there to protect the genome integrity. And if it does not exist, then there's the cell kind of like stops replicating, or basically it reaches cellular senescence and stop replicating. So that's how it might be connected to lifespan. And that has been shown in multiple species. So for this presentation, I have picked one of these examples where they have shown that earlier life telomere is kind of predictive of lifespan in mice. So they measured telomere length at the early life period, and that was predictive of their overall lifespan. And this has been done in birds as well and other vertebrates. So this has been shown in multiple animals. I use this one example for mine. Also, again, telomere shortens throughout the life, but majority of studies suggest that the trend is not linear and it could happen anytime during the life. But again, similar to like the growth period and stuff, it is shown that like it usually is maximum during the early growth phase. For example, Hull et al. 2004 showed that this was done in European sacs. They showed that there was overall trend of decrease in mean telomere length between years when they measured the telomere length from day 0 to day 2, 4, and 6, and so on. And then they also found that the telomere loss was higher during the early growth period compared to the later in life. So when they were older, the telomere loss or rate of telomere loss was slower compared to the early life period. And apart from just growth, there are various factors that can affect telomere loss. So for example, oxidative damage, it's one thing that can affect it. And there's been multiple study that has shown that oxidative damage or higher level of oxidative damage affects telomere loss. And in this case, they have shown that even growth and telomere loss are again negatively related, which could be mediated through higher oxidative damage. And similarly, this study kind of has shown that this was done in birds as well. So EB means elongated brood and RB means reduced brood. So brood is basically the number of chicks that a bird has in the nest. So for this experiment, they were manipulating the number of chicks that were initially in the nest. So for example, EB means elongated brood. Let's say the bird had 3 chicks in there, they added 2 more chicks. And for example, reduced brood means if they have 5 chicks, they reduce it to 3. So they were like changing the number of chicks in the nest. So basically why they were doing that and how it relates to my study, I will come back to that later, but they definitely saw that there was negative relationship between mass and telomere loss when they did the study. So basically what I'm trying to establish here is different kind of stressful condition during growth can affect the relationship between growth and telomeres. We've talked so far about how telomeres get shortened throughout lifespan, but there is also this enzyme called the telomerase, which typically helps in maintaining that telomere strand, but this is only active during the early embryonic growth period. So this is kind of downregulated as the chicks start getting older and older. So the telomeres can't help with elongating the telomeres. So now, as of now, I've kind of said that there is relationship between growth and telomeres, growth and lifespan, and then that might be mediated through telomere or telomere dynamics. But I also talked about how growth and telomeres might be related. And then usually, if we go back to the concept of life history trade-offs, we would expect that they would be negatively related, because if you're investing more in growth, you won't have enough to invest in telomeres, or if you're investing a lot in telomeres, you won't have enough to invest in growth. But there's been a lot of studies done on this too, and the results are usually mixed. So for example, if you look at the far left one, this was done in barn swallows, and they've shown that body size and telomeres are positively related, which is totally opposite of what I would expect. And similarly, in this like transgenic fish, they've shown that like growth and or weight and telomere loss is negatively related, and it's stronger, or like the rate is higher during early growth period. And similarly, this study was done in House Sparrow, where they selected for a larger body size, and while doing so, they ended up decreasing or like shortening the telomeres in House Sparrows. So several studies have looked at this relationship, but results are usually mixed. And especially like in one of the studies done in, or there's two studies that's been done in dormice, where they showed that there's no relationship between growth and telomeres. So some studies suggest that there is positive relationship, some suggest that there is negative relationship, and some suggest that there is no relationship at all. So what is happening? So that was something that I'm really interested in. My overall interest is in life history trade-offs. But then when I started doing this research, I realized that there's like this confusion on how these things are related. So I kind of was diving deep into this. And then one of the ways that we could potentially explain this is that the inconsistent relationship between pace of growth and telomeres among the different studies that I've shown so far, maybe because of individual quality and conditions, and they may be obscured when there is different individual variation between the individuals. For example, if we look at this graph here, so on your y-axis there's telomere maintenance, and on the x-axis growth. So these lines, the dotted lines, like when they're going from 1, 2, and 3, those are your allocation of resources. So those are allocation of resources, and the dots is acquisition. So for example, if we think about this, for this one example, there is variation in allocation of resources, because number one, I'm just going to call this 1, 2, and 3. 1 has this amount of resources, 2 has more amount of resources, 3 has more amount. But in this case, they're spending the same amount on both. So for growth, they're investing the same amount, and for telomeres, they're investing the same amount, and for for thing. So what I'm trying to explain here is like depending upon how much resources you have. So in this case, there is difference in allocation of resources, but the acquisition is the same. So when they're investing those resources, they're investing in both of those things equally. In those cases, there is going to be a positive relationship between these life history traits. But if we move to this one, we can see that there is the same amount of resources. The amount of resources does not vary. So for example, if you call it 1, 2, and 3, they're both getting 2 units of resources. They're all getting 2 units of resources, but the amount they're spending on telomeres versus growth differs. So in this case, in the last one, they're spending more on growth, which means they have less for telomeres. In this one, it's kind of in the middle, but if we go to the top, we can see that they're spending more in telomeres and less in growth. So in this case, there's going to be a negative relationship between those two. But if we look at this one down here, they have different or varying amount of allocation of resources. The allocation of resources is different, but the acquisition of resource is the same for growth. So regardless of how much resources they have, they're spending the same amount on growth, which means growth is canalized. So they're kind of paying for telomeres. So they're paying for telomeres, but they're paying less for telomeres, but they're paying the same amount for growth. And then in this term, it's called canalization of the growth. And in this case, they have different amount of resources again, but they're spending the same amount on telomeres, but they're spending different amount of growth. So in this case, telomere is being canalized. For example, if you're paying a rent, the rent is going to be fixed, right? Because every month you have to pay, let's say 15,000. But then that month you might have other stuff. So like Dasai is coming up, so that means you're buying more clothes. That means you're not going out for food, you're not going for a movie or something. So in that case, you're paying a fixed amount for rent and you're paying less amount for other things that you do. In that case, rent is being canalized. But if you get a Dasai bonus, then you will be able to spend equal on all of those. So there is no trade-off between those. So I'm trying to get into that. So time for a recap now. So we know so far that there is this thing called life history trade-offs, which is usually a trade-off between different competing life history trade because there is limited amount of resources. One of the central trade-off lies between growth and lifespan, and the growth and lifespan trade-off could be mediated through telomere dynamics. And then we've so far talked about telomere and growth could be negatively related, positively related, or they could not be related depending upon the allocation and acquisition of resources. So what do we do now then? So one of the things that I wanted to know is, what if I somehow try to increase the investment they have to do on certain things? So we've said they could canalize both of those things, but what if I add more stress, or what if I add more things where they need to invest? So that's kind of the central idea of my research. And before going into that, I want to show that this research that was done in the salmon showed that there was a negative relationship between growth and telomeres, but only for those chicks that, or chicks, I work with birds, so I always say chicks, but these are fries. So those are fish fries. Those fries that had to grow under poor condition, under the poor condition situation, there was a negative relationship between growth and telomeres. But for those that grew under a favorable condition where they were not stressed, where they had enough resources, then there was a positive relationship. So some study have shown that this relationship, or the expected negative relationship between growth and telomeres, might only be exacerbated during a stressful condition. Similarly, in case of the great tits, there was a negative relation seen in the last hatch chicks. So last hatch basically means that usually in different kind of passerines or birds, chicks usually hatch in different order. So if there's 5 eggs, the first laid egg hatches first, and then the second and third and the last usually is the last laid egg. So that means the first laid egg or first hatch chicks already has enough food and it's already big, and it begs and competes for that food when the last hatch chick hatches. So that it means it's getting more food compared to the smaller one, and the smaller one is at disadvantage of already having lesser food to start with. So that way they don't get enough food. And similarly, this study has been done in European sags, where they have shown that handling those chicks usually affects their relationship as well. So now what is my question then? So my question, well, I've included only 2 of my questions for this presentation. So the first one is, how does natural variation in developing condition influence relationship between growth and telomere loss in developing chicks? And the second one is, how does an experimentally induced stress exposure during prenatal development influence the relationship between growth and telomere loss? So for the research system, I work with House Sparrows, and we conducted this research on pre-established population of House Sparrow here in Fargo, North Dakota. One of the reasons that it's really nice or house sparrows are really nice to work on this system is because if you look at this chick on the left side, that's day 2, and then the one on the right side is day 10. So they go from day 2 to day 10 in with, or like this to that within the span of 8 days. So they grow really fast, and plus they are readily like they readily breed in the nest boxes, which is easier to catch. So the method we use is like nest boxes are usually monitored from April throughout August. And then once the eggs are laid, we regularly visit the nest boxes to see if they have hatched. And then once they hatch, from day 2 through day 10, we measure their growth structure. So like wings, mass, tarsus, and then also we take blood samples from them at day 2 and day 20. Oh, day 2 and 10. So for the first question, when you looked at this, there was no effect of any of those environmental variables in relationship between growth and telomere loss, and growth and telomere loss by themselves were also not related. So there was no relationship between them. However, air significantly affected telomere loss as well as date and telomere length. So this could be kind of suggested that depending upon different year, and then the place I live in is very cold. It's kind of like the northernmost part of the US, and we get a lot of snow and it's usually cold. So early season or like every year differs, right? And then there might not be enough food one of the season, and there could be better condition the other one. So that's why we see these differences between the years. So it's kind of suggestive that it might depend upon food resources or depend upon environmental conditions as well. And Julian date also influenced mass at day 10, and growth was higher later in the season. So growth was faster or growth was higher later in the season. This also kind of suggests that early in the season, like April or May, it's not warm enough and there's not enough insect or there's not enough food for those chicks. So that's why they're growing slower. But when the condition is good later in the season, they're growing faster. So far for the first experiment, we saw that there's no negative or any kind of relationship between growth and telomere. That is something that I'm really interested in. And then we didn't see anything there. And this was just done under natural circumstances. There was no stress or anything. But what if we add more stress to that? So for this experiment, what I did was I cooled the eggs. So this question basically is like, how does experimentally induced stress during prenatal development affect relationship? So for this one, once the classes were complete, we assigned the nest to either cool or control treatment. For the cooler ones, we took the eggs out every day for 3 hours until they hatched, and they were maintained around 28 degrees Celsius. So birds usually incubate their eggs around 36, 38 degrees Celsius. So we brought it down to 28, and then we kind of kept it around 28. And growth measures, including mass, tarsus, and so on, were measured similarly for this project as well. And when you look at this one, we kind of found this super interesting thing. So if you look at this, so before getting into this, I want to say that there was no effect of the treatment on the relationship between growth and telomeres. So cooling the eggs prior to hatching did not affect their relationship postnatally. During the growth period, there was no relationship or there was no interaction between growth and telomeres in affecting the growth and treatment in affecting the telomere loss. But something interesting that we saw, which kind of relates to my first experiment, is that growth rate was higher for the cooled chicks, and that was later in the season. So basically, they were also small at day 2. So while at hatching, chicks from the cooled egg were smaller at day 2, and then they were smaller early in the season. They were growing slower early in the season where there was not enough food, but later in the season when it got better, they started growing faster. And if you look at the graph, they even got so faster or like started growing faster than the controls ones later in the season where the condition were growth. So basically we kind of induced this compensatory growth in those chicks. Compensatory growth basically refers to like whenever they're compensating for growth, which they could not earlier in the season or like during unfavorable condition, but when there is favorable condition, they started growing faster. So basically, going back to the conclusion and discussion, our data does not reveal any kind of negative or positive relationship between growth and telomere loss under natural condition or even during the pre and postnatal conditions. So I've not included the postnatal condition experiment in this one, but So I also did another stress experiment. So similar to the cooling one, for that one, we took the chicks out of the nest and held them in a cloth bag for 1 hour every day from day 2 to day 10. So even during that time, we did not see any relationship between telomere loss and growth. So for some reason, at least in maybe house sparrows, there is no relationship between growth and telomere loss. So that could basically be explained through various things. And one of the things that I'm trying to look at right now is maybe those relationship or those trade-off are only seen in certain kind of tissue. So I've already told you guys, like they are that small looking thing and they need to be a bird looking thing within the span of 8 days. By the next 4 days, they need to get out of the box. They need to fly. So from day 2 to day 14, they have to be able to fly out of the nest. So to do that, they need to grow faster. So maybe growth is canalized, but when they're growing that fast, they also are in risk of losing their telomeres faster. So maybe they're investing equally on growth and telomeres until they flares. So maybe both growth and telomeres are canalized for them. While that happens, they're maybe not able to spend in other tissues equally. So maybe these negative effects could be localized to various tissues, which I am working on right now to see if that's difference between various tissues. And maybe also they might only be seen later in life. So there are a few papers that kind of suggest that these effects are seen much more later in life and not during early life conditions. That could also be true because the telomerase activity could still be, there might be some residual telomerase activity in the chicks until like day 6 or 7. And then we did the experiment from day 2 to day 10, meaning that if there's still some telomerase residual left from the like embryonic growth, then maybe that's obscuring our relationship between growth and telomeres. So basically, so far, those are the results I have. And maybe it just doesn't exist in sparrows because that's how they are, or like they're kind of species that needs to go fast. So maybe for those, both of those things are canalized. And with that, I would like to bring out my acknowledgement side. We have an amazing lab, and then all of these people have helped me a lot during field works and all of the analysis and suggestions. Special thanks to my advisor, Dr. Britt Heidinger, Dr. Rebecca Young, and also very huge thank to Jeffrey Kittleson for helping me with all the lab work. And then with that, I'll move on to the questions. I don't know about the time, but I think that's like.
Thank you, Mr. Anuj. You are exactly on time. Thank you for that. And also thank you for providing us very informative presentation. Now we will move to question and answer session. If any one of you have question, please put on your question. Okay, I have one question for you.
Yes.
What are the different resources you are included in this study which affect the growth and telomere maintenance?
Oh, so you're asking me what kind of different things
resources, yeah, resources which you have included in this study.
Oh, brood size. So brood size basically is number of chicks that are in the nest. So they're siblings. The other thing is hatch strength. So basically, which is did you hatch first or did you hatch last? So like there's usually 5 or 6 chicks in house sparrow nest. So we have the hatch ranks in there, have the brood size in there. There is sex included. So male and females usually have different growth rates. So sex is in there. And then Julian date and what else? Yeah, those are the stuff that was included in the model, but none of those things affected the relationship.
Thank you. Is there any other question from audience? You can also message the question in the chat box. I think that's all for today. Thank you, Anuj.
Yeah, thank you for inviting me.
Yeah. And now I did in the section. See you.